Okay, so today we are going to add and subtract rational expressions. And so it's just like when you add and subtract with fractions. If you have a like denominator, you add or subtract the numerator. And then if you can, you reduce the fraction. So if we look at example 1, we've got 7 over 4x plus 3 over 4x. So I just add my 7 and my 3, and I get 10 over 4x. And then because they're both divisible by 2, I can reduce it to 5 over 2x. If you're subtracting, you want to make sure you subtract everything that's in the numerator. This example, there's just a 5, so that doesn't really do much. In fact, you know what? I'm going to change it just to kind of make the point. Let's make it 5x plus 3. Okay, so because what happens is that what I see happening is people will remember to subtract the 5, but they'll forget that also the 3 has to be negative. So you want to make sure that you pay attention to what's being subtracted and that both things get subtracted. So if I do that, now I've got a plus 2x and a minus 5x, and so that would be negative 3x, and then I just have a minus 3, and then on the bottom I have x plus 6. And so even if I factor out a negative 3, nothing will divide out, because then I just have x plus 1 here. So there's nothing that cancels out. So you could write your answer in either form. It's not a bad idea, though, to factor just to double check if anything cancels out. But in this case, nothing does. So, all right, so on your whiteboards, we'll start off with a simple one for you. Okay, looks like most of you guys were getting that. It was 1 over 6x after you reduce it. All right, and here's another one for you. All right, so when we add them together, we got the 2x squared plus 2. We can factor out the 2, which is the greatest common factor. And our final answer is just 2. Okay, so before we go into adding and subtracting with unlike denominators, I want to talk about finding the least common multiple. The least common multiple is what you use. It's also your least common denominator, okay? So when you're finding the least common multiple, you're saying, what is the smallest thing that both of these expressions will divide into evenly so that stuff cancels out? And so we're going to do an example where we find the least common multiple of 4x squared minus 16 and 6x squared minus 24x plus 24. So the first thing I need to do is factor the two polynomials. So I've got 4x squared minus 16, and I've got 6x squared minus 24x plus 24. So when we're factoring, what's the first step? What do we usually do first? Take out the GCF, right? So if I do that, I have 4, and then I've got x squared minus 4. And so that can factor into 2 times 2, so I'll just write it as 2 squared. And then times x minus 2 times x plus 2. And then for the second one, I can take out a 6, and I'm left with x squared minus 4x plus 4. That becomes 2 times 3, and then it's x minus 2 times x minus 2, which I'll write as a power, x minus 2 squared. So then what you want to do is you want to look at each of the factors. I've got a factor of 2, I've got a factor of 3, a factor of x minus 2, and a factor of x plus 2. You need to take the highest power for each factor. So what I'm doing is I'm kind of looking at them by columns. These are my factors in columns. And to get the least common multiple, I take the highest power from each of those columns. So in the 2 squared 2, my 2 squared is the highest power. And then in the 3 column, I just have one of them, so 3 is the highest power there. In the x minus 2 column, I've got one of them that's squared, so I need to have it squared. And then finally, I have to have an x plus 2. And so my least common multiple will be 2 squared times 3 times x minus 2 squared times x plus 2. So if I simplify that, it would just be 12. And then x minus, I would leave it factored though. You don't want to multiply this all out. Okay? So my least common multiple is 12 times x minus 2 squared times x plus 2. So what I'm doing is I'm finding something that they'll both divide into. So I'll just to show you that they both divide into it, if I have 12 x minus 2 squared x plus 2, if I put my 2 squared and my x minus 2 and my x plus 2 on the bottom, is everything going to go away on the bottom? I can't divide all of those things into the top? I can, right? The 4 goes into 12 3 times. One of the x minus 2's goes away, and the x plus 2's go away, right? And then the same thing would be true if I put the other one on the bottom. If I put the 6 and then the x minus 2 squared, is it going to go in evenly? It is, okay? So that's the point of finding the least common multiple, is finding something that they will both go into evenly, okay? All right, so, and we're going to use that when we start getting common denominators. So let's first try and do this one on your whiteboards. Find the least common multiple for 5x cubed and 10x squared minus 15x. All right, so when we looked at the factors, we have to have a 5, we have to have an x cubed, we have to have the 2x minus 3, so the least common multiple is there. All right, so we're going to use this when we want to add and subtract with unlike denominators. We're going to use it to find, so we can get a common denominator. So first we have to find the least common denominator, which again is our lowest common multiple. Same thing, okay? So, so if I look at my denominators, I've got 3 squared times x squared. Here I've got 3x times x plus 1. So if I look at each of the factors, I have to have a 3. What's the highest power of 3 we see? 3 squared, right? I've got to have a 3 squared, so that's a 9. I've got an x squared and an x, so I've got to have an x squared because I take the highest power, and then I have to have an x plus 1. So my lowest common denominator is going to be 9x squared times x plus 1. So now, just like when we had our numbers, when we had, I don't even remember what the numbers were now, something over 18 and something over 72, we took this one and we multiplied it by 4 to get it to the 72, right? So it's kind of the same idea. We're going to multiply by what's missing to get to the least common denominator. So first let me just rewrite the problem. Okay, so if I look at the 7 over 9x squared, I've got the 9x squared. What's missing? What do I need to have? I need to have 9x squared times x plus 1, right? So what am I missing from that first one? The x plus 1's missing, right? If I want the denominator to be 9x squared times x plus 1, I'm missing that, aren't I? Whatever's missing on the bottom, you got to multiply the top by the same thing because you can't change the value. All right, let's look at the second one. I've got 3x times x plus 1. I don't want 3x, I want 9x squared. So what do I have to multiply it by? By 3x, right? So I'm going to multiply it by 3x over 3x. Because now I'll have a common denominator. What's on the bottom of both of them now? 9x squared times x plus 1. Okay? All right. So let's go ahead and distribute. Do you see it now? Okay. So I'm going to go ahead and distribute that one and then just multiply the x and the 3x. So if I distribute, I get 7x plus 7, and then x times 3x gives me 3x squared. And then on the bottom of both of them now, I've got 9x squared times x plus 1. And so nothing can be factored on the top. I'm just going to rewrite it in standard form. Put the x squared first, then the 7x plus 7. And all over 9x squared times x plus 1. So sometimes you may run into a problem where it can actually be reduced after you do it. In this case, we can't. So we'll just leave it like that. Okay, I'm going to show you guys a subtraction problem too. And then if we have time afterwards, I'll have you guys do a couple problems on whiteboards, okay? Okay, so we're going to have x plus 2 over 2x minus 2, and we're going to subtract negative 2x minus 1 over x squared minus 4x plus 3. So the first thing I want to do is factor the denominators and find the lowest common denominator. So the first one, I can take a 2 out, and I have x minus 1. And then x squared minus 4x plus 3 is x minus 3 times x minus 1. So my lowest common denominator is going to be 2 times x minus 1 times x minus 3. Everybody follow that? Is it starting to make a little more sense? Yeah. Okay, so let me rewrite the problem again. X plus 2 over 2 times x minus 1. All right, before I write the second half, though, I want to make sure you guys distribute the negative. So I'm going to distribute the negative to everything on top. Okay, so again, that's something you want to be real careful with. Make sure that you don't forget to do that. All right, so with it written that way, now it becomes a plus sign, and it comes to x plus 1 on top, and I've got x minus 3 and x minus 1. So if we look at the first one, on the bottom I have 2 times x minus 1. So what's missing? The x minus 3, right? So I'm going to do this times x minus 3 and this times x minus 3. I'll go ahead and put parentheses around that one. And the second one is just missing the 2. So we'll do this times 2 over 2. And so now I just have to distribute and see what I end up with. So x plus 2 times x minus 3 comes out to x squared minus x minus 6. And then if I distribute my 2 over here, I get plus 4x plus 2. And all of that now is over the 2 times x minus 1 times x minus 3. And so then we combine our like terms, and I get x squared minus x and 4 plus 4x gives me plus 3x, and then negative 6 plus 2 gives me minus 4. And then I want to see if I can factor the top and reduce it if possible. So my x squared plus 3x minus 4 does factor. It's x plus 4 and x minus 1. And on the bottom we have 2 times x minus 1 times x minus 3. And so I see that I've got an x minus 1 on the top and the bottom. And so I can reduce it, and the final answer would be x plus 4 over 2 times x minus 3. Okay, questions? No questions? Okay. Okay, so that's all we have time for. And yeah, if you guys have questions, you can see me after school. Watch the video on YouTube. I'll be the one